All right. So good evening again, everyone. So this is our next session or second session on this differential equation. Right. In the last class, we have discussed these topics, right? Types of differential equations, order of ordinary differential equations, formation of differential equation of the curves. And in today's class, we are going to discuss these topics. That is types of solution of differential equation. One of the type we have already discussed, that was variable separable form, right? We a few more questions we will do today, and then types of first order and first degree differential equation. I already told you what does it look like actually and how do we solve it. We will study later also different methods. So then method to solve the first order and first degree differential equation. Okay, so to solve the first order and first degree differential equation, there are numerous methods we discussed in the last class, and out of which one we have discussed already, variable separable form. Now today, this session will be totally uh, in this session we will totally cover the equation which are reducible to the variable separable form. Okay, so at the direct means directly if you look at the equation, it will not look like you can separate x and y x and y separately for the dx and dy respectively. So some modification we have to do in this case, right? Some modifications. And what are those modifications? We are going to understand first of all few questions based on the variable separable, and then we will go further to study about the equation which are reducible to variable separable form. So let's start with the first question. So the first question is, find the equation of the curve satisfying the dy by dx is equal to x ln x passing through the point e comma 1. Okay, so if you want to try it, take your time. Okay, take your 1 minute and try this. Tell me what is you're getting. So in this case, same thing is there. We have to do the check whether the separable form is working or no. Okay, variable separable form is working or no. If it is working, then follow the procedure what we have studied in the last class, right? So what was the procedure? Let's discuss. If you see the question, it's a simple question, right? Very easy question given. Dy by dx is equal to x into ln x given. Now what is this passing through the point of e comma 1? What is this? Actually, if you remember, I told you in the last class that some of the boundary conditions will be given in order to find out the value of that constant. Which constant? The constant which you get after doing the integrations, right? That c value, and that c value will be calculated based on this input, or we can say boundary conditions which is being given. Now what is this e comma 1? It says that if you put x is equal to e, y will be equal to 1. These are the coordinate format they are giving you. So it is clearly saying that e is equal to, x is equal to e, y is equal to 1. However, the different way to represent this boundary condition can be like this also. Y bracket e is equal to 1. Since y is a function of x, and they are putting the value of x as e. And this total value, when you're putting x is equal to e in the y equation, you're getting the answer as 1. So they can give you in different formats these boundary conditions. You have to understand that whether how to use this, right? So this is the boundary condition given. Let's go for the solution then. So if we see, we can easily separate them, right? Because x ln x into dx, there is only one variable, right? So it is easy to solve. Now what is the next task? Integration. Integrate both sides. So when you will do the integration, what you will be getting? Integration of dy is equal to integration of x ln x. And if you remember this type of integration, when two functions are in the product, we use the by parts rule. Okay, or we can say product formula in the integration. So how do we say that? How do we use Eilert principle, right? According to the Eilert principle. So in this case, x is algebraic function, okay, and ln x is the logarithmic function. So first logarithmic is coming and then algebraic is coming. So therefore, logarithmic function will be taken as the first function and x will be taken as the second function. Or you can say this is u and this is v. Okay, whatever the way you have studied. Now the formula was, I'm writing here, formula was u into v dx, u into v dx is equal to nothing but first as it is, that means u as it is, integration of second minus differentiation of first into small uh, integration of second of whole dx. This was the formula for by parts. Okay. So just directly use that and get your answer. So in the left side, you can see it will be y only. Okay. Let's go to the next page. So in the left side, let me write here. It was dy is equal to it was dy is equal to x ln x dx. Or rather, I can say, let's write like this, ln x into x, because why I'm writing like this? Because this has to be taken as u and this has to be taken as v. Okay. Now apply the formula. Left side will be simply y only and the right side will be simply, when you do the integration, first as it is into integration of second minus the differential first, derivative of first ln x, sorry, not minus, small integration with the integration of v dx. V function is nothing but here x, so x dx. Okay. And the whole dx also. So just do the integration. X integration is x square by 2, simple, minus derivative of ln x function is nothing but 1 by x. Integration of x will become x square by 2 and whole dx. So this x and x is gone and you are getting x square by 2 into ln x minus integration of 1 by 2 we can take outside and this will be remained I think x only, right? X dx. So that can be easily integrated, x square by 2 into ln x minus x integration is nothing but x square by 2, that is it will become x square by 4 plus c. Don't forget this c, right? Because the whole question is depending on this c. Now this is the general equation we have got, but they are now asking the particular solution. Particular solution means they are giving you the boundary condition as well. So since the boundary condition has been given, now you will put the value of x in this and y also and get the value of c. So it is given it is given it is given that y is equal to 1 at x is equal to e. Okay, so y will be equal to 1. Put this in the equation, put in, let's say this is equation 1, put in equation 1 and that's how you'll be getting e square by 2 and this is ln. Achha, ln is nothing but log natural. Ln is nothing but log natural. So log natural means base is e. So this is log base e. X value is e minus e square by 2 4 plus c. So log base e, it will become 1 only. So e square by 2 minus e square by 4 plus c and equal to 1. So from here you can get the value of c, right? The value of c will be, when you take the LCM and all thing, this will become 1 minus e square by 4. This is the c value. Now what is the next task? Put this c value again in equation 1. In equation 1. And that will be the equation of the curve which is required. Okay. Let's go to the next page. So c is equal to 1 minus e square by 4. We can directly put that in the equation. So y is equal to The equation was y is equal to x square by 2 into ln x minus x square by 4 plus c value was there. So c value is 1 minus e square by 4. And that's how you will be getting your final answer. Okay. Any doubt so far in this? Anyone? Clear? Everything clear? Okay. Let's go to the next part. All right. So answer was already given. Same answer you can see on the right side. The next question. Next question, it has been asked in JEE Main 2020, as you can see. So I'm going to give you a 1 minute time. Okay. So try this and tell me what you are getting. Check whether this variable separable, because we have studied the variable separable only right now, right? So try to check whether it is working or no in this question again. If it is working, then go ahead. Boundary conditions are also given in this case, right? These are the boundary conditions again. So I said to you already, if it is given like this, y of minus 1 by 2, y of 1 by 2 already given, right? So 1 second. So means at x is equal to 1 by 2, they are giving you the value of y. Okay. So this means that at x is equal to 1 by 2, y value is root 3 by 2. So first you have to find out the y from the differential equation. The student who will get the answer, you can directly unmute, right? I cannot see the meet window again and again.
First
Yes.
option.
Yes. First option. Okay. Any other student got? Yes. First option is correct. Good. Let's solve. Let's solve this. So in this case, the equation is given like this: under root of 1 minus x square dy by dx plus under root of 1 minus y square is equal to 0, in which mod of x is less than 1. Okay. And conditions are given at y of 1 by 2. The value is given as root 3 by 2. And then they are asking y at minus 1 by root 2. Achha, in this case, they have gone to a next step, one step ahead. Okay. After getting the c value, they are saying after getting the complete equation of the curve, after putting the c value, you have to find out the y value at x is equal to minus 1 by 2. Okay. So this means that at x is equal to 1 by 2, y is equal to root 3 by 2. And this has been asked, which what is it? Okay, at x is equal to minus 1 by root 2, what is the value of y? Right? So first of all, you can see this is under root of 1 minus y square, 1 minus under root of 1 minus x square. So we can try to separate them. Okay, this is under root of 1 minus x square dy by dx. Let's take the under root of 1 minus y square on the right side. So this will come with the negative sign. Okay, now this is in the terms of y and this is in terms of the x. So what we will do, we will take the y terms on the same side of the dy and x terms on the same side of the dx, right? So let's try that. So we can say that dy by under root of 1 minus y square is equal to dx upon under root of 1 minus x square with the negative sign also. not integration once again. Integration we have not done yet. Okay, so this is the equation we are getting. So after that, the next step is integrate. So as the moment you do the integration, it will become dy upon under root of 1 minus y square is equal to minus integration of dx upon under root of 1 minus x square. And after doing the integration, you will get a constant here. Acha, you might be remembering this formula. This was the direct formula, right? This was a direct formula, that integration of 1 upon under root of 1 minus x square dx was what? Sine inverse of x. Okay, if it is y, it will become sine inverse of y. That is not an issue. So here you can say it will become sine inverse of y is equal to minus sine with sine inverse of x. Actually, it is x by a, right? So it is 1, so we can take directly x only. So plus c. Okay, this is clear. Now we can directly solve it. Let's go to the next page. So we got the equation sine inverse of y is equal to minus sine inverse of x plus c. Now the conditions are given, right? Conditions are given at x is equal to 1 by 2, y is given as root 3 by 2. Okay, so let's say this is equation 1. Now put them in equation 1. So you will be getting sine inverse of root 3 by 2 is equal to minus sine inverse of 1 by 2 plus c. What is the value of sine inverse of root 3 by 2? That will become 60 degree, right? Pi by 3. And this sine inverse of 1 by 2 will give you 30 degree, right? And plus c. Now from here you can find out the c value, which will be coming as pi by 3 plus pi by 6, 60 plus 30, 90 degree. Okay, very easy question. The c value we have got directly. So now again put the c value in the question, means in the equation 1. Okay, again put the c value in the equation 1. So put in equation 1. When we will put in the equation 1, we will be getting sine inverse of y is equal to minus sine inverse of x plus pi by 2. Okay, this is the final equation we are getting. Now the question has moved to one step ahead. So they said ki you have to find out the y value at x is equal to minus 1 by root 2. Okay, so we will put that in the equation 2. Put in equation 2. We will be getting sine inverse of y is equal to minus sine inverse of minus 1 by root 2 plus pi by 2. Sine inverse of minus theta, we can take it as minus of sine inverse theta, sine inverse of x. Sine inverse of negative of x can be taken as minus of sine inverse of x. And when this negative sign come outside, it will become positive one. And sine inverse of 1 by root 2 is nothing but 45 degree, right? Pi by 4. So pi by 4 plus pi by 2, 90 degree plus 45 degree, 135 degree, that is 3 pi by 4. So we are getting sine pi by 4, sorry, sine inverse of y value as, so we are getting sine inverse of y value as, I'm writing here, right? We are getting sine inverse of y as 3 pi by 4. So the y value will become sine of 3 pi by 4. And that will be actually nothing but 1 by root 2 only, because pi minus pi by second quadrant. Okay, so what is the answer? A option is the correct answer. Is that clear?
Yes, sir.
Let's go to the next page, next question. Yes, so the answer was A option, as you can see. Next question. Again, take 1 minute and try this question. Tell me the answer.
Again, first option, sir.
Okay. It's an easy one, right? Okay, you can mute yourself. Whoever is unmuted. Hmm, correct. Let's solve this quickly. It's an easy question. So it is given as dy by dx is equal to e to the power x minus y. Okay, further this can be written as e to the power x into e to the power minus y, right? And now I think you already have observed it is directly the variable separable form, right? So we can write this as e to the power x upon e to the power y, and then cross multiply. So e means take the y terms on the same side and x terms on the same side. So e to the power x into dx, and then integrate. So as we do the integration, we already know that integration of exponential function is remains same unless and until that exponential is raised by any power or multiplied by any constant. Okay. So in this case, one second. So in this case, it will become e to the power y only, and it will become e to the power x only and plus c, right? So this will be our final equation, and option A is the correct answer, right? I hope that this is clear. Okay, this is the question. Let's go for the next one. Next question again. So this was the answer. Next question. It has been asked in JEE Main 2020. If y is equal to yx is the solution of the differential equation 5 plus ex upon 2 plus y dy by dx plus e to the power x is equal to 0, satisfying the y. See, the same condition is given again. Satisfying y at x is equal to 0 is given as 1. Then again, they are asking the value of ln 13. So in this case, they are saying at x is equal to 0, y is equal to 1. And they are asking the value of y at x is equal to ln 13. They are asking the value of y. Okay, try this and tell me what you are getting. Take 1 minute. Yes, any answers?
Sir,
Yes.
sir, what does it meant by y equals to y function of x? The initial part of the question.
They are saying that y is a function of x only, right?
Oh,
Means it is saying that by the differential equation, when you will get the y value, which is actually the equation of the curve. So see this y is actually the equation of curve, and yx is saying that it is the function of x.
okay, sir.
Okay.
So second option, sir.
Yeah, second option is correct. Great. Good. So let's solve this. Let's solve this question. 5 plus e to the power x upon 2 plus y into dy by dx plus e to the power x is equal to 0. Okay, and the conditions are given. Always when you are solving these questions, no matter whether you are in the board, especially in the boards, right? Write this like this: at x is equal to 0, y is equal to 1. You will never do the mistake. Okay. So first of all, we'll try the separation, whether it is possible or no. So let's try the separation. So first of all, take that e to the power x on the right side. So this will become dy by dx is equal to minus e to the power x, right? After that, I think it is clearly visible that it is a direct separation. So we can say dy remains as it is here, and 2 plus y remains as it is here. Dx will go there. So it will be e to the power x upon 5 plus e to the power x into dx. Okay. So this is, I think you are getting, and now you can do the integration. Integrate both sides. Remember that in the differential equation, whenever the question comes, first task of yours should be try that check whether the separable form is there or no, whether you can do the separation or no. Because sometimes they will give you a very complex equation, okay, but after little bit solving, after solving little bit of that equation, you might observe that this is a clear cut of variable separable form. Okay, as you can see in the JEE Maths also they are giving you this kind of questions. Now, at this point, since we have studied only one method, so that's why you are able to solve, right? But when we study like 3 4 methods continuously, then you will start becoming confused, because 4 to 5 methods are working in your mind at a time, right? So that's why most first that's why the first method or first way to deal with any question in the differential equation, to deal with the first method, okay, or we can say to try that whether it is separable or no. So integrating both sides, that will give you dy upon 2 plus y is equal to minus times of integration of e to the power x upon 5 plus e to the power x plus c. It's not c, sorry. C will be used after the integration. Okay. So integration of 1 by 2 plus y, it is a linear format. So we can directly say that it is ln of mod 2 plus y is equal to minus. And in this case, can we use the substitution rule? Directly we can use the substitution rule. So if you take 5 plus e to the power x as t, it will become e to the power x dx as dt, right? So dx is also there. So therefore, it will become simply 1 upon t into dt, or rather I say minus ln t plus c. Mod you can apply and then replace the value of t. That is 5 plus e to the power x plus c. And in the left side, you are having ln of mod 2 plus y. Okay, this is simple equation you are getting, and now we can go to the next page and we will try to solve it further. So the equation is ln of mod 2 plus y is equal to ln of, in the bracket, mod 5 plus e to the power x plus c. Now take the ln on the left side. Okay, ln of 2 plus y mod plus ln of 5 plus e to the power x mod is equal to c. And you can see that it is the clear cut. You can use the formula of the log m plus log n, which is nothing but base is same, so which will become simply multiplied. Okay, is equal to c. And we can further solve it if you want. Okay, but let's not solve it. Let's put it like this only. And let's try to put now the y value, the conditions. First condition was given. Let's say this is the equation 1. First condition was given.
Sir,
Yes.
sir, can you reshow the substitution part, sir?
Substitution part. Yeah.
Sir, I have a suggestion.
Yeah, tell me.
Instead of C, can't we use ln C, because ln and ln would get cancelled. Ln is still like anything. Anyway, it's gonna be a constant.
That will. I know. That will come by practice. At this point I'm not using that. Okay. In future, when you do a lot of question practice, you can directly use that ln c, right? I know that you know that thing. Yes, Rajat, you are saying something.
Done, sir, done.
No, sir.
Okay.
No, sir. I'm not.
Okay. So directly put the values now. What are the values given? It is has been at x is equal to 0, y is equal to 1. Put in the equation 1. So ln of mod 2 plus 1, okay, into 5 plus e to the power 0 will also become 1 is equal to c. So finally it will become ln of mod 3 into 6, right? 3 into 6. 3 into 6, and that will simply nothing but 18. Okay, since it's a numerical value, we can directly take the positive sign. So ln 18 is the value you are getting for the C. Is it correct? Hmm. So now put that in the equation 1. Put in equation 1 again. So we will be getting ln of mod of 2 plus y into mod of 5 plus e to the power x is equal to C value, which is ln 18. Now the question was asking the value of this total function. This is actually the our equation of curve. This is the equation of curve. Okay, now the question is asking that at x is equal to ln 13, what is the value of y? Right? So let's put that value. So when we will put this value, it will become ln of 2 plus y. We have to find out that into mod of 5 plus e to the power x. Achha. Ln 13 means we can write it as log base 13, right? Log 13 base e, sorry. Log 13 base e. Log 13 base e is equal to log, or we can say ln 18. So this value will become what? This value will become base and base are same, so it will become 13 only. 13 plus 5, 50, 18. Okay, so this value when you solve it, it will become ln of 2 plus y into 18 is equal to ln 18. Sorry, 13. 13 plus 5, 18. Okay, correct. So ln 18 is equal to,
Sir,
yeah.
addition symbol, right, sir? Okay, okay.
Okay. So from here we can say ln and ln will be gone. If you take anti-log on the both side, the ln and ln function will be gone. Into 18 is equal to 18. This 18 and 18 is also gone. So we are getting mod of 2 plus y as equal to 1. So therefore, two values can happen. So 2 plus y is equal to plus minus 1. So from here, y value will be either minus 1 or minus 3. So finally, you can say, therefore, y at ln 13 will be equal to either minus 1 or minus 3. Both are possible. So second option. Okay, this is clear. Again, an easy question.
Yes, sir.
Let's go to the next question. So this was the answer, B option. Next, which of the following is true for y of x that satisfy the differential equation dy by dx is equal to xy minus 1 plus x minus y, and it is given that at x is equal to 0, y is also 0. JEE Main 2021. From differential equation, you can easily solve the questions in the JEE Mains if you have practiced enough. Okay, so I'll recommend that at least complete your books. Well, that is school books, right? Whatever the NCERT books is there, at least complete that once so that you can understand the pattern, how they are asking the question in the. However, you will see that repetition will be there, right? Means pattern is same. Okay, the equation will be different. That's it. So in this question, what you will do, you will again try to think or again try to do whether the separation is possible or no. Anyone got the answer?
Fourth option, sir.
Fourth option is the right answer. Correct. Good. So let's solve this. So dy by dx is given as xy minus 1 plus x minus y, and it is given that y at 0 is equal to 0, means at x is equal to 0, write this condition like this: at x is equal to 0, y is 0, right? So first of all, we'll try to separate them if it is possible. So let's see. If we can see, this is xy, this is y. Let's take the y common from both of them. So it will become y common, so x minus 1. Similarly, in these two parts, this will become x minus 1. And if I multiply 1 here, then we are getting two factors, that is y plus 1 and x minus 1. Now it is one of the easiest question. Okay, variable separable is directly working here. So dy by y plus 1, take the left side, or take this y plus 1 in the left side, and x minus 1 into dx, and then do the integration both side. So sometimes the question directly will not be looking like it is from the variable separable, but you have to check by hook and crook, right? Okay, so integrating both side, you will be getting dy upon y plus 1. So left side will be log, right, into dx. So left side will be ln of mod y plus 1 is equal to integration of x will be x square by 2 minus 1 integration is x plus c. Now the conditions are given. Put the conditions and get your c value. So let's go to the next page. So we have got ln of mod y plus 1 is equal to x square by 2 minus x plus c. Okay. Now at x is equal to 0, let's say this is equation 1. At x is equal to 0, y is equal to 0, put in the equation 1. So ln of mod y is 0, this is 1, is equal to this is 0, this is 0 plus c. So you can see ln of 1 will become also 0, this value is also 0, and this is 0. So totally you will get c value as 0. So therefore equation of curve will become however in this question curve is not mentioned, so we should not write it. Okay, we should not write it. We can simply say that the equation will become. So when they are giving you the, however, of course it is representing a curve only, but since they have not mentioned equation will be ln of mod y plus 1 is equal to x square by 2 minus x. That's it. So this is the final equation we are getting. Now they're asking, okay, I think we have to modify it then, right? We have to solve it further. We have to solve it further. So we have to solve it further. Okay, let's see. So from here we can say the mod y plus 1, we can write this as the ln will go right side. If you take the anti-log both sides, so it will become e to the power x square by 2 minus x. Okay. if you don't remember, log of x to the base e, x is equal to if it is given a. So x value will become what? E to the power a, na? That is coming from where? By the, someone said something. Yeah, B option. Okay, so let's solve this further. So from this mod, you can get the two values. So y plus 1 is equal to plus minus e to the power x square by 2 minus x. Or I can say y is equal to y is equal to minus 1 plus minus e to the power x square by 2 minus x. Okay. Now again, we can apply the condition here, right? Because again, a constant is given here. Again, a constant is given here. That's why we can apply the again condition here, which is given to us at x is equal to 0, y is equal to 0. So let's apply. So at x is equal to 0, y is equal to 0. Putting this in the equation, we will be getting y is equal to minus 1 plus minus e to the power 0, because 0 minus 0 will be 0. And this will become minus 1 plus minus. Is there any mistake we have done? Yeah. Hmm.
Sir, I think that you should substitute x equal to 1 because all the options that you got.
Exactly. Exactly. This is the missing question, missing
Just
part in the
directly
question.
give the values.
Correct. Okay. I got a mistake. Yeah. So they are saying already ki in the question ki y is equal to 1 we have to put, right? Sorry, x is equal to 1 we have to put, and then we have to find out the y value. Correct. So we have done the slight mistake here. Yeah. So at x is equal to 1 we have to check y value. So y value will become minus 1 plus minus e to the power 1 square by 2, that is 1 minus 1. So this will be giving you minus 1 plus minus e to the power minus 1 by 2. Okay. So two answers will be there. Either it is e to the power minus 1 by 2 plus 1, or either it is e to the power minus 1 by 2 minus 1. And only one is matching, I guess. Okay. So D option.
Yes, sir.
So y at, you will be writing y at 1 is equal to e to the power minus 1 by 2 minus 1. This is the final answer. Okay. Someone has joined, I think. I don't know why they are joining at this time. Achha, no one has joined. Let's go to the next question. Next question before the question. Yeah, next question. So D was the answer. Yes, can you try this one? It is saying solve the differential equation dy by dx is equal to cos of y minus x. Check whether the variable separable format is working here or no. Yes, anyone got the answer? If you got, you can tell me by unmuting yourself, or other I have to check them.
Sir, we
Any
can
hint?
use that formula no, sir, cos of a plus b by 2 and that from half angle formula.
Half angle formula.
Not the formula, sir, exactly.
Huh. Separation of trigonometric formulas. How?
How, like separation, sir, cos a y plus cos x would be plus sin y plus sin x would be equivalent to
Uh,
cos a y minus x, sir.
plus sign will be there. Cos y cos x plus sin y sin x.
Yeah,
Like this.
that's it. That will be equal to cos y minus cos in cos y minus x, sir. Y minus
But
x.
but try check that whether after doing that you are able to separate them or no. That is the real question,
No, sir. No, sir.
right? So yes, any other
Separation
method?
is kind of hard, sir, at that matter.
In this part, right?